Hello everyone, welcome to the Equation Web. Today we will be doing two arithmetic problems. Let's start with them. Today's questions are rational expressions and equations. They focus on series and cubic functions. So today's first question will be, find all positive integers n for which 1 over n plus 1 plus 1 over n plus 2 plus so on and so forth up to 1 over 2n is an integer. I'll give you guys some time to do this question. So there are three things that we need to list out before we start solving this question. The first of which is that there are exactly n terms in the sum. This means that from 1 to 1 over n plus 1 to 1 over 2n, there are exactly n terms. We know that the largest term is 1 over n plus 1 because the larger the denominator gets, the smaller the fraction in this sum. From the same logic, we can figure out that the smallest term in the series is going to be 1 over 2n. So we can say that the total sum is Sn, and that this total sum is in between 1 over 2n and 1 over n plus 1, as this inequality says. Now, since there are n terms in this series, we can multiply both sides by n and simplify those fractions in order to get a much better inequality that will help us find the solution. So once we simplify that, we get that 1/2 is less than Sn is less than n over n plus 1 is less than 1. You may wonder where less than 1 came from, and that came from the fact that n over n plus 1 is always going to be less than 1. Because, for example, if we take the fraction 2 over 3, that is in the form n over n plus 1, that is less than 1. 5 over 6, same thing. 4 over 5, same thing. So that is why it's always less than 1. So then we can remove the n over n plus 1, and we can keep that Sn is always going to be less than 1 and greater than 1/2. This means that n cannot be an integer because there is no integer in between 1/2 and 1. Our last question did not have an integer solution. Let's try this next question. Find all positive integers n for which 1 over n plus 1 over n plus 1 plus 1 over n plus 2 is equal to 1 is an integer. The first step in order to solve this question is going to be to make common denominators and combine these later on so that we can get an equation that we can solve easily. Now we just combine all of these fractions into one big fraction. Next, we can expand out all of the parentheses and multiplication that we have in order to simplify. Then we can combine like terms in order to get this full fraction. 3n squared plus 6n plus 2 over n cubed plus 3n squared plus 2n equals 1. We can then multiply the denominator on both sides in order to get rid of the fraction and simplify. Then we get all the terms on one side to get this equation. N cubed minus 4n minus 2 is equal to 0. Let's plug in 1, 2, and 3 into this equation to check if any of those are our integer solutions. As you can see, none of them are our integer solutions. As you can see here, since we plugged in 1, 2, and 3, we can see that if we plug in 2, we get negative 2, and if we plug in 3, we get 13. Our answer needs to be 0, which means that the answer must be between 2 and 3. Since our answer is between 2 and 3, it means that our answer is not an integer solution, which means this question does not have any integer solutions. Like our last one, this one doesn't either. This is a lesson, since not all questions are going to have integer solutions or a solution in general. Thank you for watching, and make sure to like and subscribe.